Capacitors and inductors have the interesting property that there are certain parameters which can change instantaneously and other parameters which cannot. So capacitor voltage and inductor current cannot change instantaneously. Capacitor voltage and inductor current cannot change instantaneously. And so the intuition for why this would be the case is that capacitor voltage and inductor current define the stored energy. And energy, the stored energy, cannot change instantaneously. It has to be delivered or absorbed. So intuition, these parameters define the amount of stored energy. The amount of stored energy. So to remind ourselves, the equations were that the energy in a capacitor is 1/2 CV squared, and the energy in an inductor is 1/2 Li squared. So the voltage on the capacitor and the current in the inductor can't change instantaneously, because if they did, then the energy that is stored there would be discontinuous, and that doesn't physically make sense. So we have this important property: capacitor voltage and inductor current cannot change instantaneously. So often you will see this written. So often this is written as something like this, that if you have a voltage on a capacitor at a certain time, let's say like a little bit before something switches, so this 0 minus notation here means a little bit before time 0, that the voltage at 0 minus is equal to this voltage at 0 plus. And so just to clarify this notation here, 0 minus means just before t equals 0, and over here 0 plus means just after t equals 0. So implication being that t equals 0 is a time when something turns on or turns off, or a switch moves or something like that. So capacitor voltage and inductor current are continuous across any transitions in the circuit, but the same is not true for the other parameters. So however, the current flowing through a capacitor and the voltage across an inductor may be discontinuous. Right? When we say discontinuous, we means that it could change instantaneously. So we could have that the current in a capacitor at 0 minus may be different to IC at 0 plus. It's possible that they are the same. It depends on the circuit, but it is possible that they're different. So that's important to recognize. So what you need to remember is that it is the capacitor voltage and the inductor current which are kind of stable across any instantaneous changes to the circuit. And if you forget which way around that is, just think back to energy, and it's basically that the energy can change instantaneously. And so no instantaneous change in energy means no instantaneous change in capacitor voltage and inductor current.